Today we're going to be looking at solving quadratic equations by graphing. Here are the couple standards that you need to be aware of. And to be successful, you need to solve quadratic equations by graphing, be able to use graphs to find the appropriate zeros of functions, and be able to use technology to find a quadratic model for a set of data. You have one new vocabulary term today. It is a quadratic equation. A quadratic equation is a nonlinear equation that can be written in standard form, ax squared plus bx plus c equals 0, where a is not 0. So the big takeaway from this, every quadratic equation is going to have an x squared. So the highest degree is going to be a 2. And standard form means your exponents go in descending order. So x squared, x, and then the constant term has no variable. All right, your key ideas to solve a quadratic equation by graphing. Step 1, write the equation in standard form. Step 2, graph the related function. Step 3, find the x-intercepts if there are any. All right, so real solutions or roots of ax squared plus bx plus c equals 0 are the x-intercepts of the graph. Again, solutions or roots, you'll see this term. If it asks for the roots, that means it's asking for the solutions or the x-intercepts of the quadratic equation. All right, solving a quadratic equation, solve by graphing and check your solutions. All right, the first thing we're going to do is set the equation equal to 0. So we're going to put it in standard form. So we've got x squared plus 2x, and then we have equals 3, so we're going to subtract 3 and move it to the other side. Now we have a quadratic equation in standard form. All right, so we may be able to factor this, but let's go ahead and plug it in our calculator because it says solve by graphing, so we can quickly type this in and see what it looks like. So we're going to have x squared plus 2x minus 3 and hit graph. All right, it looks like we have a couple points on here from before. Let's turn off my scatter plot. The stat plot, the scatter plot must be points from my table from a previous example. So let's turn that off so that we're not seeing those points. We just want to see the equation that we're currently looking at. We can see that it goes through -3 and +1. All right, -3 and +1. So let's say -3 and +1. We can see it looks like the vertex. Well, let's find the minimum value. Calculate the minimum value, number 3. Let's go to the left of the vertex. When it says left bound, you've got to be left of the point you're looking for. And it says right bound, so we've got to go right of the vertex. This helps the calculator isolate this value in between these two spots, and then you hit enter again. And it says your minimum value is about -1, -4. So -1, -4. All right, so this question doesn't really say I have to do it by hand or using technology, so that's why I use my calculator to graph it, but I also want you to see that if you need to graph it on paper, you can do that as well, as long as you have your intercepts. If it crosses the x-axis, that's going to be your 2 x-intercepts and your vertex. So Again, I found that using my calculator. We will learn how to do that by hand as well, but for now, that's how we're going to look at the graph. All right, that's not perfect, but it's pretty good. So let's look at how that relates to this equation. So x squared plus 2x minus 3. So we graphed it, and it says -3. So x equals -3 and x equals 1. That's my x-intercepts or my 0. And it says to check your answer. So you can do that by plugging the numbers in. So we're just going to take -3 and plug it into my equation there. All right, so I've got -3 squared plus 2 times -3 minus 3. If that equals 0, that means this is a solution. So I'm going to do negative. Make sure you put your -3 in parentheses before you square it. And then I've got plus 2 times -3. And then I've got minus 3. And that equals 0. So we can conclude that -3 is a solution. Let's try 1. So 1 squared plus 2 times 1 minus 3. You probably can do this just as quickly without a calculator, but there you go. You can quickly see that both of these are solutions. We found the x-intercept. These are called zeros of a solution. And we plugged them back in the original equation to check it, and it made a true statement so that we know those are the two solutions. So example 1 does have two real solutions, and your solutions are the x-intercepts, -3 and +1. All right, to save a little time, I want you to try this one on your own. Go ahead and use your calculator if you want to graph it. Find your x-intercepts and your vertex, and then plug it in and check it. I'll be back in just a moment to help you do this one. Just pause your video, work it out, and then come back and see how you did. All right, hopefully you took a minute to pause your video and see if you could do this on your own. If you graphed it, hopefully you've seen that the x-intercept was at -1 and +2. So -1 and +2 are your two zeros, and those would be your solutions. So your zeros are your solutions. Okay, also called roots. These are called roots. All right, so plug in -1, you get 0 equals 0. Plug in 2, you get 0 equals 0. So both of these are your solutions. Example 2, solving a quadratic equation. This is an example that has one real solution. So let's see what that looks like. All right, it says solve by graphing. So again, we're going to set this equal to 0, x squared minus 8x. I have equals -16, so I need to add 16 to both sides, and that makes that equal to 0. So we put this in standard form. Remember, standard form is x squared, ax squared plus bx plus c equals 0. A, b, and c are just numbers. So this puts it in standard form. And again, we can use our calculator to quickly graph it. So you can see I've got x squared minus 8x plus 16. And I hit graph. And you can see 1, 2, 3, 4. So it appears that the x-intercept here is 4. So it looks like it's only hitting the x-axis one time. So 1, 2, 3, 4. So that means our vertex is going to be on the x-axis. All right, so if we look at this in another way, we can look at this by factoring. So we can say x minus 4 squared, that equals 0. All right, so this term in factored form would be this. If I take the square root of both sides, I get x minus 4 equals plus or minus 0. Since there's no plus or minus 0, it's just 0. Add 4, and you can see that x equals 4. So that would be our 0. All right, so we can let's sketch a curve here real quick. All right, and then it always says to check it. So how would we check it? we would simply take 4, plug it back in, and see if it works. So let's do that. Let's do, this time we can plug it into the original equation. So let's do 4 squared. You can put it in parentheses, but since it's a positive number, you don't have to. Negative 8 times 4. All right, and if this is correct, I've got x squared minus 8x, where 4 is x. If 4 is your solution, when I hit enter, it should equal negative 16, because I put this in the original equation, and it does, negative 16. So 4 squared minus 8 times 4 equals negative 16. So that's an easy way to check it to see if that is a solution. So this would be your solution. All right, example 3 says solving a quadratic equation that has no real solutions. So remember, our solutions come from the x-intercepts. So if it has no real solutions, this quadratic equation will not cross the x-axis. So let's see what it looks like. All right, first thing again, we need to put it in standard form. Negative x squared. I need to subtract 2x to the other side and subtract 4 to the other side. Now that I have it in standard form, I can just simply plug it in and graph it. So you can see here, I've got negative x squared minus 2x minus 4. When I hit graph, it gives me this parabola. So it does look like 1, 2, 3, 4. It does look like at negative 4, it has an x-intercept. So we could graph a point at negative 4 here. All right, we also can find the maximum value by doing second trace. Maximum is number 4. Remember, again, I have to do left bound, so I have to go to the left side of it first. So what it's doing is looking for that highest or maximum value. So I have to go to the other side of the highest point and hit enter. And then it's going to say the maximum is at pretty much negative 1, negative 3. So negative 1, negative 3. So at negative 1, 1, 2, 3, there's another point. And you know the axis of symmetry goes through that point, so you can reflect this point over to here. So you could sketch that graph using those 3 points. All right, that's pretty good. All right, again, this one would be considered no real solutions. So that's all you have to put. This one would be no solutions because it doesn't cross the x-axis.